For the remainder of this unit, then, we will be covering statistics, and the first PowerPoint and activity we're going to do is an introduction to summary statistics, and a lot of that, I think, is going to be a review to you when we talk about mean, median, mode, range. However, doing things like calculating standard deviation by hand, you may not have any experience with that, so that may be new information, but we'll talk about that in today's PowerPoint. So statistics is defined as the collection, evaluation, and interpretation of data. And we can use statistical analysis of the measurements to verify the quality of a design or process. And we're going to use this specifically with our puzzle cube project. We can look at the individual wooden cubes that we'll use to build the final solution and measure, determine how close they are in size to each other and whether or not they fall within an acceptable range. We're using all statistics to do that. So we're going to talk about central tendency, which has to do with the center of distribution, which is our mean, median, and mode. We're going to look at variation, which is the spread of values around the center. And we're going to do that using range, standard deviation, and then interquartile range. And then finally, we're going to look at distribution, which is the use of either frequency tables or histograms to kind of show the distribution of our data, along with discuss the concept of normal distribution. So we're just going to touch on that at the end of this PowerPoint. So let's start with mean then. The mean is going to be the sum of the values of a set of data divided by the number of values within that data set. And there is an actual formula for calculating the mean. In this formula, this is our symbol then for the mean. Our X is the individual data values of our data set. This is the summation symbol, which means that we're going to add up all of the individual numbers within our data set, and then N represents the number of data values within that set. So to calculate the mean, I'm going to add up all of the values in the data set and divide by the total number. If this was the data set we were using as an example, if I were to add all these up, I would get 243, and then I would divide by the total number, 11, and get a mean of 22.09. Let's talk about rounding as it relates to statistics. Okay? As a general rule, we don't round until we get to our final answer. If you're writing intermediate results, you may round values but keep unrounded numbers in memory. And as it relates to the mean, we're going to round to one more decimal place than the original data. So original data was whole numbers. There were no decimal places. We're going to round to the first decimal place. For standard deviation, which we'll cover later on in this PowerPoint, round to one more decimal place than the original data. So we'll look at that in just a bit. So going back to our mean, if we calculate the mean 22.09 repeat, our original data had no decimal places. We're going to round to the first decimal place, and so I would report the mean as being 22.1. All right, let's talk about the next central tendency, which is the mode. It's going to be the most frequently occurring value in a set of data. That's the mode. The symbol for mode is a capital M. Using this data set, I'm looking for the data points that occur most often. It is easier if you rearrange this in numerical order from the smallest to the largest, and then look for numbers that are reoccurring. So if I'm looking at this, I see 21, there's two 21s, and this is going to be the mode for this data set. Okay. There are circumstances, though, where you have more than one set of numbers that are occurring most often. If you have two numbers of equal frequency that stand out in your data set, that data set is said to be bimodal. If it's more than two numbers that occur more frequently and stand out, then we have what's called a multimodal data set. Right? So we can have the mode if there's just one, bimodal for two, or multimodal for anything more than two. So we'll look at the three examples of each. 63 is what's occurring most often. That's the mode. In this case, I see 63 and 59, so this is a bimodal data set. And then looking here, I see 63, 59, and 48. This is considered multimodal. And then the last central tendency is the median. And the median is the value that occurs in the middle of a set of data that has been arranged in numerical order. So we do need to arrange it in numerical order find the midpoint. The symbol is x tilde, so x with a little tilde symbol above that represents the median. If this is the data set, the first thing I need to do is I need to arrange it in numerical orders from smallest to largest. And then I'm looking for the number that falls directly in the center. Okay. So because this data set is odd, I have an odd number of data values, the median is going to be in the middle of that set. Right? Looking at here, it's 21, meaning that there are 5 data points to the left and 5 data points to the right. So the median is the one directly in the center. Now, there are circumstances where we're going to have an even number of data values. Right? And when I do that, then my median is not going to fall right on my numbers. So if I count 1, 2, 3, 4, 5, 6, and then 6 from the other side, my median falls directly in the middle of these two numbers. So to determine the median, then I take an average of the numbers closest to that, which would be 21 and 23. Take those, divide by 2. I'm going to find the median to be 22. So in this case, our median isn't even part of our original data set. It's because we had an even number of values. Okay. All right, let's talk about range, which has to do with our variation. The range is going to be the difference between the largest and the smallest number within our data set. And the symbol that we will use to represent range is going to be R. So if this is my data set, my largest number is 44. I'm going to subtract my smallest number, which is 3. And I'm going to get a range of 41. It's fairly straightforward. All right, let's get into standard deviation. This one, maybe not something that you've done before, so we'll spend a little bit of time on that. The standard deviation is the measure of the spread of data values. And a larger standard deviation indicates a wider spread in our data values. This is the formula that we will use to calculate standard deviation. This is the symbol for standard deviation. X is going to be our individual data values within our data set. We have the mean as part of the calculation, and then n, the size of the population, which in this case is going to be the size of our data set. To calculate the standard deviation, then, we have to first calculate the mean. So I'm adding all the data values together, dividing by the total number within that data set. I'm subtracting the mean from each of the values and then squaring each difference. So I'm taking the mean, subtracting it from each of the data values, and squaring the difference. I'm going to sum all those square differences up, divide by the size of the population, which would be our n, and then calculate the square root of that to get the standard deviation. Right, so there's a lot of steps, but the math associated with this is pretty straightforward. So using this data set as an example, let's go through the process then of calculating standard deviation by hand. Calculating the mean first would be adding each of these up and then dividing by the total. So I have 11 data points, 524 divided by 11 is 47.63. I'm not going to round any of this until we get to the very end. We talked about the rules for rounding. We'll wait till we get to the end. Subtract the mean from each data value and square the difference. So I'm taking 47.63, subtracting that from 2, and squaring that answer. And I'll do the same thing for 5, 48, all of the values within my data set. Again, now we're getting lots of decimals. We're not rounding those till we get to the very end. Next, I'm going to sum all the differences, which is basically adding all of these numbers up that we calculated. I'm going to divide that by the total number of data values, which was 11. And then finally, I'm going to take the square root of that to find my standard deviation. At that point, I rounded to 1 decimal place based on the rules that we talked about here. So standard deviation in this case of 21.4. So doing this by hand, although there's a lot of steps, is not very difficult. If we had a ton of data values, like we had thousands of them, obviously we wouldn't want to do this by hand. We would use Excel, or we would use a graphing calculator to do that. And we will in future activities, but for today's activity, we will do this by hand. All right, last thing then is the distribution. And we would use a histogram as a common data distribution chart used to show the frequency with which specific values or values within ranges occur in a set. As an engineer, you might use a histogram to show the variation of dimension that exists among a group of parts that are intended to be identical. In our case, the 3/4 inch wooden cubes we're using in our puzzle cube project are ideally going to be 3/4 of an inch, but if we were to measure them with a caliper, some are going to be a little bit bigger, some may be a little bit smaller than exactly 0.750. And so we can use a histogram to show that distribution of values. If we have a very large set of data, we can often divide those into a limited number of groups. These groups are called class intervals. So if I had hundreds and hundreds of data points, and I didn't want to plot every single data point on my diagram, I could break them up into class intervals, meaning in this case, anything between -16 and -6 would be here, -5 to 5, and 6 to 16 would fall there, right? And I can use this information to determine the frequency. So I know that there are 5 set of data points that falls between -16 and 6. There are 7 between -5 and 10. I'm sorry, -5 and 5. And then there looks like 3 between 6 and 16. So if this is the data that I was using as an example, rather than plotting every individual point on here, I would group them individually. Right? So 1, 4, and 5 falls within this class interval, 7, 8, and 10 in that class interval, and then 12 and 15 in the last class interval, and that gives us our histogram. So this would be a common example of one we would do. This looks like they're using the puzzle cube data as their example, and I can read this by looking at, okay, 0.75, if I were to measure, I found that 4 of my cubes were exactly that size. Some of these were smaller and some are larger, and we can start looking at maybe some of the outliers, ones that are too large or too small to work for our project. Shows us where our min is, where our max is, and then again, where the mean probably is, or the center, and then the frequency that occurs within our histogram. Another way to think about doing this is a dot plot. It looks fairly similar to a histogram. With a dot plot, I use dots instead of the bars for each of the data points. So this would be our data points, and then we can count to determine the frequency. So this is just showing each of the points being placed on our diagram. And then I can determine the frequency based on the number of dots that are coming along. So either way works for this. In Excel, we'll probably use histograms because creating a dot plot is not necessarily easy to do. All right, finally, let's talk about normal distribution. It has to do with the shape that our data takes as we place it on, let's say, a histogram. We're looking for data that's bell-shaped in nature, meaning that most of the data points fall in the center, and the farther you get from the center, the fewer data points that you find. Now, it's not perfectly symmetrical on both sides of the middle, but this would be considered normal distribution based on the shape that we see of the data. And we're going to get into this a lot more, talking about normal distribution in some activities and some PowerPoints coming up. So let's look at today's activity then. We're going to be starting activity 3.5, Applied Statistics. And for this activity, we will be using this as our data set. So all the calculations we do are based on this data set. Given these numbers, I want you to calculate your mean, your median, and your mode. We also want to calculate the range for that data set. And then by hand, calculate standard deviation. They've given us this diagram to help you stay organized with that. The first column is to place each of the data points from your data set. The next column then is your data points subtracting the mean, which you calculated previously in this activity. And then I want to square those differences. So I'll put those numbers in here. Those can all be added together to give me the sum. And then the last couple steps to give me standard deviation is to take this, divide by the total number within that data set, and then take the square root. That's going to give us our standard deviation. Last part of this is to create a histogram. You're going to plot all your data points along here, and then your frequency along here. If you choose to do class intervals, meaning you're going to group them together in intervals, what would be the appropriate size to do that with? And that's what it's asking you in question D. Lastly, there are 2 conclusion questions that I want you to answer. You can work directly on this Word document. Make sure that your answers are in a color other than black, please, so I can delineate your answers from what was originally there. And I'm going to give you the next 2 days to work on this before we move on to the next activity. When you're done, save this Word document, and submit it for 3.5 on the LMS.